It's 12 o'clock, and it's time for another daily episode of a little bit about our xChips. Sorry, guys. So, today it's going to be the interesting concept of interconnectivity. So, what do I mean about interconnectivity? Well, that's the various ways you can connect the xChips within the same circuit. So, we're going to talk about the physical connectivity of our xChips together. I'm going to say within other circuits, of course, you can make two circuits and they can communicate, that can connect to each other using radio or Wi-Fi or other means. So what I'm talking about here is that you want to have them together and maybe a little bit different from our normal way. So that's what we're going to talk about. We're not going to get into the technical stuff about the signals that's going via the one another, but we are going to talk about which of these various technologies, interconnectivity technologies, that have limitations for which signals. So there might be a little bit of that, but otherwise it's very much more like the physical way we connect our xChips together. So here's a summary of the ones that I want to talk about. We have our XC10, which is our normal connector. There's not a lot to say about that because that's the one we've been using all the time. And in my little diagram here, you can see here that the direction of how they connect is horizontal. So they're flat, they're lying next to each other. So when I have two xChips, like I have these two here, for example, if I connect them together in a horizontal plane like that, using a connector, obviously. Then I'm talking about here if they're full or part connection. And what I mean by that is that it's all the 10 signals that we have going through, because some of the connectivity we have to cut down on what we can connect together. So on the connector, our normal connector, all 10 wires goes through. Then it's whether it's kind of wire solid. That's kind of like giving an idea about how flexible it is or how robust connectivity you have, solid or wire. And then there's distance. That's kind of like how far can you get your xChips away. And I'm very simple in my categorization here because I'm going into detail. Is it low or high? So low being like within a hand, you probably have to have a hand width, so like 10 centimeter or whatever. And high is considerably higher. There's only one of those. I'll get into how far that is. And then there's flexibility. And of course, that's kind of like directly related to the wire. The more we use wire, the more you can put together your circuit in any way or form. And the thing is, just hang on, just want to check here. Yep. So if you use a wire, then of course you can twist the xChips together in various ways, and that will help how you put this thing here together. And then I just have a note here. So the XC10 is our standard connector. The AI04 is the one they're using, something that looks like a phone cable. It's not 100% a phone cable, so I put like a couple of codes around it. Then the AI05 is a flat cable. The M1x series, because there's more than one xChip there, is stacking. So that's like the vertical plane. So of course with wire, any direction, horizontal or vertical. But with the M1x series, it's a stacking connector. And when we stack them, we are talking about, they're growing in a vertical plane. And then the BS01 is also a vertical stacking solution, and that's based on the PC104 standard. So I have it here. That's live. So the PC104, the PC104 standard is like the vertical. It's also a vertical stacking, and that follows this PC104 standard. As a PC104 is like a standard for how to connect single board computers that had existed for a very long time. So there's a really lot of PC104 single board computers that typically considerable expensive, 10, 20 times more than, for example, a Raspberry Pi. So it's more like the traditional old school single board computer, if I can use that. And then I just have a little bit about production. So of course the normal connector we have in AI04, the cable one we have, the AI04 and the M1x we are ready to put into production, but we haven't put them in production yet. And then the BS01, we right now only do it on per order basis because it's a very low volume requirement for the PC104, simply because typical the PC104 stuff is so expensive in the first place. So it's not something that flies out the door. I'm also just going to talk a little bit about other xChips that kind of like fall into this area, and it's like some of the stuff is internal, so something we use internal in between our xChips. So it's not like something we necessarily going to educate on, and we don't have any production xChips that are using any stacking today. So that's kind of like more the future, and then some old and odd stuff that we have been that we either are planning with or have been playing around with. So let's start with the AI04. So the AI04 is the one I have here on the screen here. So this is a kind of like a telephone cable. So it looks very much like a telephone cable here. So it's this is a ready-made cable, and this connector that sits on the AI04 is hang on a second. It's like a telephone plug, if I can put it that way. So the AI04 here, you can see here that I don't know how close you can see it, but there's like 4 little gold fingers here. So only 4 of the 10 pins come through here and goes to the other end of this thing here. So let's look into the details about that. So here on the screen you can see here I say that the I2C, so the 2 of the pins of the 4 is I2C, and the 2 other is power, the normal circuit power, 3 volt and ground. So that's the 4 pins. And I2C here goes up to 40 meter. So you can have a circuit that's 40 meter apart. We haven't tested if the power, I mean, there shouldn't be any reason why it shouldn't be like that. We haven't tested if we have enough power to go across. Again, that probably depends on also on the quality of the cable and on the circuit on the other end. But you can always just put a battery on the other end. So it's not like you not necessarily have a solution for if you get to 40 meter and the power is not strong enough. You can always put like a coin cell battery or something else on the other end that helps the circuit in the other end. So that's power. Let's look at the cable, because this is the one that probably gives a little bit of gray hair when people want to get the cable. So you first of all can make your cable yourself, but if you can buy it ready-made, then that may be an idea. So what I have here is a screenshot, and I know the text is a little small, but don't worry, it's going to be zoomed in just now. So here I have selected that I want 6P4C or 6P6C, and I'm coming into detail what that is. So that's the round circle on the top, and then the oval in the lower right corner say reverse, and that talks about how the cable style has been mounted in that connector. So let's dig into that. So the connector that sits on these cables here, they're called RJ11 in general. So it's an RJ11 cable, and there's different versions of the connector that sits. There's the 4P, 4C, and the P stands for how many positions it can take. and the C is how many that's been used. So 4P is that it's 4P wide. And you can see those that called 6P has the same width. They're like 6 position wide. And in a 4C, you can maximum have 4 cables connected. So there's 4C. And in a 6P wide, you can have either 4 or 6 connected. And since that one is too small, and the two other 6P, 4C and 6P, 6C, that both works because we're only using the 4 middle cables. So it doesn't really matter what kind of cable you have of the one or the other of the two last versions here. And then this thing here about its reverse, as it says in the lower right corner, just means that the cables have to be straight and not crossed at all. So position number 1 have to go to position number 1, position number 2 to position number 2, and so on. They just have to go straight. So that one we can't use. If I show you here on my screen, let's see here if I can actually show you that close enough. If I take this out, and then it might not be visible. Here we go. No, I don't think you can see it, but if you can see it, the irons go to the same irons in one end to the other end. So they're just like going straight through. So on TDKey, where I looked up these cables here, they say reverse, and on my diagram up here it says straight pinned, and TDKey call it reverse, but that doesn't mean everybody else calls it reverse. So it's important you understand the straight. If you look at the data sheet, it will tell you by a drawing that number 1 goes to number 1, and that's what you need here. So that was the AIO5. Then looks at our flat cable. So the flat cable I have here. So this is a short range cable. So you can see here's a cable here that's very short, and you can actually get these cables in even shorter version. You can see here I have one here for another project, but it's the same cable. It's kind of like very short, but that allows you to kind of like put something together at any angle here. And this is the longer one, and that's fine too. That allows you to kind of like put a circuit in where you kind of like, you can make a 90 degree, or you can put it like odd out. So there's 20 wires in this cable here. So each of the 10 positions inside the chip here has been duplicated. So the same position, the same cable on the outside on both, number 1 and number 20 here is the same. So we kind of like from outside into the middle have duplicated all the wires. So if the cable breaks, or if there's a solder position that's slightly loose or whatever, then there's a redundancy built into this cable here. So we simply have all the position here duplicated over the cable, and of course not next to each other. That will not be right, but we actually have them so they're mirrored. So that also means that some of these connectors, some of the cables might be upside down. So you don't really have to worry if you put the cable in the wrong way around, because it's mirrored, so it will work in both positions as long as there's connectivity on both sides. So you're not going to break anything when you put this thing here together. So this is the AIO5. So you simply have an AIO5, and it's just a connector. There's nothing here. There's not like a booster or any other chip here. So what you do with this one here is that you can connect 2 of these, and that allows you to, for example, let's say you want to have a display, or you want to have a sensor that have to face the other way around, or whatever it is, then this solution is a good little solution here. Of course, it costs you 2 xChips in size, so it's not going to be necessarily the smallest, but it allows you to kind of like deal with these odd out installations you might want to do, and you don't necessarily want to create a whole new xChip series that's connected, or let's say the AIO4 is too bulky for what you actually are looking for anyhow. The next one I want to talk about is our stacking, our M1x stacking here. So Here I have a circuit. So this circuit here is just a circuit with, well, in this case 8 xChips, but it's kind of like laid out like 3x3 xChips. So here's a battery module we're playing around with. Here's a SL19 we had like a talk about yesterday. Here's a CW2 and an A802, which is like the new security chip. I had another daily on that. Here's our weather sensor. Here's our light sensor, and down here we have another weather sensor. But the important part is here, and that's difficult to see in this configuration, so I'm going to hold it up like this thing here. So you can see this is like a little stacking thing, and what that allows me to do is allows me to take and put xChips in. So for example, I can connect a xChip like that here. So I have this, MD12, so I just have to turn it right side around because this thing here can be used both ways around. So I have now a 2-layer, 2-stacked solution here. So you can see here, I just have to hold it up right. So you can see here is the solution here for the stack here. Where do we have it? There we go. So here it's stacked. So how does that work? Well, so the way we make it, maybe it's an easy way to kind of like explain this thing here. So we have these connectors here that we put like in a stacking configuration here, and we have this thing here that this is our normal 2-layer stack, and we have a 5. We also have a 3 and a 7. So the whole idea is that you can stack just a single stack, or you can stack multiple xChips layer with this thing here. So I'm going to show you the way this one here was made. So what we have here is that we actually have these, and you don't make them, they are ready made like that, but it's actually, the reason I'm just showing is so you can kind of like get a understanding of how this thing here was put together. So this is actually how they're put together here. So of course there's more in the middle, but this is actually how it works. And then they're soldered in together like this thing here. So it holds itself together like that. Now, when you, this xChip here is similar to the AI4. It only provides power and I2C. So there's only power and I2C going from one layer to another layer. So when I go back to my circuit here, so in this case here, I have this MD12. So the MD12 is the same as the MD01. It's just shorter. So if I take this out, you can see how it looks like. So it's like shorter like that. And that is so it allows space for the stacking without actually interrupting the size of this thing here. Because that size is the size so it can actually go into like a 10 by 10 centimeter frame, which is kind of like a CubeSat style frame. And the CubeSat style frame, we use that a lot simply because when we a lot of other experiments that we send out to International Space Station or into space, we might want to stack it to kind of like get a more compact solution like that. Now you can see here that the battery here is so big that I just have to get it here. So when I stack here, I can't actually get to the battery. So what I could do is I could simply use a bigger stack like my 5-level stack here. So I put that together, and then of course I can easily get over the battery, as you can see here. So the other thing is that so let's put back the original one here, and then I put my MD12 in. Before I go on, I'm going to show you another stack here, and you don't have to use the MD12. You can stack without using the MD12. So the MD12 costs you a position, but if you just want to stack without, and then you can just stack on the outside. You don't have to actually use any kind of like MD12 to stack. You can simply just have it on the edge here. And the reason why this is also important is because you can use the same stack So if you take this one here and turn it over upside down, you can hardly see the difference. The only way you know it is actually if you click it into the other side, so like here. So now I have my normal stacker down here, and I have this thing I turned over. Now 4 other pins are actually being connected here. So now you have other signal pins and other power pins. Not all 10, but 8 of the 4. You might not be interested in another one, so you shouldn't necessarily stack for that reason. But what you can do is that if you have a circuit that's like flat enough and same size, this stacking on the other side, of course, offer some kind of like stability, so it's not like just hinges on the one side here. That you can also just do by having spacers put in, you know, in between your different stacks, which is like the normal way, so you will just have a stack here. And of course, you can have 2 stacks like that in the same side, so now I'm turning it back over, like that, and then you have a redundancy put into your circuit, because now there's 2 power wires and 2 I2C going from one level to another, similar to you will have between your different xChips. So the other thing I want to show is if I take one of these out, what we have done is that because we stack, we've done like a MD11, so that's a MD1, but it just have a window in, so you can see here that with that window you can see the xChips underneath. So the whole idea with having the MD01 is that when you stack, you might have something in like the second layer, and it have to be visible in the next layer. So you obviously will prefer to put that sensor on the top layer, but it might be for other reasons. And we also use the MD11 for some of our other stacking options, the PC104. That's actually where we made it, but you can use it in this solution here also. So as I mentioned, there is a 5, there's a 7, we have a 3, and I have a 2 of these ones here. And we'll come out in production, we're going to figure out which of these ones that we are going to come out with first. We're definitely going to come out with the 2-layer stack, but we might come up with, for example, a 5-layer also. So that is the, and this is called, these ones here, it's called MI15 when it's 5, and this is called MI12 when it's 2. So these are MI1, so 11 is actually this little chip here, so we have internal, and MI10 is one in here, and then 12 and 5, and there's MI13 with 3 and MI17 with 7. So that's our stacking solution. So let me take that away. Actually, let me just keep this part here. And we need a few connectors. So I think that should do. So let's get back to the presentation here and go to our next one. So our next one is our PC104. So the PC104 is almost look like what I have on the screen here. So there's it's called 104 because there's 104 pins here. So in this one here, I haven't soldered in the pins. So this one normally will have a lot of pins, so it will stack on top of another one that looks like that, and it will have pins. So it will have male on the bottom and female on the top. So you will be able to actually stack these up like this in multiple different layers. And then we have like another one, so we call this thing here, we call that east. So if I turn it around like that so you can see it, and this one here we call west. Okay, so if I go back to the presentation here, you can see here I'm talking about PC104 compliant. That is that in our talk here is that when you put 4 xChips into the stack, and then we have PC104 bus compatible. That's when you put 6 chips in, because in a bus compatible they kind of like talk about that you can use more space, and actually there is an overhang standard, and we fall within the overhang standard. So even though that we are bus compatible, we also overhang compatible, so it falls into that slightly bigger space. That means that we still fall in within 10 by 10 centimeter. So let me just demonstrate that. So on
Question from Gary.
yes, just hang on. I get a question here. Yes. So Gary asked if I will with this stacking solution here can actually stack up to 10, and you can indeed. So if I take, for example, here I have let's take these two here. So let me just pause this stuff here for a second. But if I take this and say, for example, I have my circuit here, I can then put the one stack in here, like that. Another stack I put in like, oops, just have to do this. So you can see here how I didn't make it 10 high, I made it 9 high. Gary asked if I can make it 10 high by putting it together, and of course I can also put a 2 high in between and then make it exactly 10 high. So I can put that in another layer here that was stacked together by the 2 high, and that way I will have a 10 layer higher if that's the important layer here. So Gary, hope that answered the question. Others feel free to come back. I'm going back to the PC104 here. So so what I'm going to do here is I'm going to show that, and the way it works here is that you kind of like would put it together so the text matches here. So if I put the, and you can see here that I have 5 connectors down the side here. And that's because I reuse the position. So I can't use all 4 positions. So let me get it in there. And then I can't use all 5 positions. I have to use the 2 in between or the 3 that's on the outside. Okay, so now I have the one that is in this document here. It's called PC104 compliance. Sorry, so that's this one. Let me take this out so there's no confusion. So this is this way here. And of course, remember there's pins here, and you can then stack it up. And then if you want to do the overhang version, then what you do is that you connect your circuit here. So sorry, let me put it on the other side. So I now have my 6 xChips connection. Of course, I have to move these ones to in between here. Sorry, let's get it around like that, and I click it together like that. And then this one here, same story. So let me put it like that. And then I can click that in, and now I have my overhang version. So it's still 10 centimeter here and fall within the PC104 standard. These holes have a very specific position that's important for the PC104. So this, because we actually want to fly this thing here on CubeSat into space, we're a little bit nervous if this thing here could fall apart. So it's a structure to hold it. So what we've done is that we developed this motherboard here. So what happens is that you actually can take this and then you can screw that in. So that will typically sit underneath, and it have like this slight distance. And the holes in the board here, the big holes here fits these holes that sits here. So let me just get in the picture here, there, and there. So this is these holes that sits in this corner, and these other holes here will fit with the xChips standard holes that you have on a board. So you can screw the xChips to this frame here and the outside of the frame, and you will then have a stack that fits within the standard 104 stack. You can see that underneath here there's a hole here, so the pins that come out here, the metal pins that come out from this one here, is not blocked. So this kind of like creates your PC104 standard board. and you can fly it on a CubeSat, or you can use it for learning. We have a whole long video about CubeSat standard where I'm using this in here, so I suggest looking through this if you're interested in PC104. But there's thousands of single board computers. There's a PC104 standard. So if you have an old one here, you have an opportunity here to connect. We have these pins here doesn't have necessarily a very solid standard. So there is a standard developed over time for power and I2C, and there's a loose standard for UART, but since we're using I2C, we use those. And there's two standards. So we have on the back here a solder position here where you can tell whether you use the one I2C standard or the other one. And then you can, and the power is a standard. So that's the only thing you have to configure in order to use that in your various layers. Then you can communicate with all your sensors here, or you can even put yourself a little single board computer in, or whatever you want in that layer here. So PC104. Now I want to just come back to some of the other xChips here before we close off. So we had like a old internal stacking here. So this is actually a stacking here that we had because we needed to kind of like have more communication between some of our xChips. We got away from that. It's a quite expensive one. So instead of that, we have a new one here, and what we're using this stacking for is also to kind of like allow a component that takes up the full space. So because the stacking underneath actually have connectors all the way around, then we can actually fit this one here, and this one is actually a satellite radio. So we really want to try to fit it into one module. Normally, if we have something that size, we will, have to put it on a 2x4, so we could have connectors on the side. So in this one here, we instead have this stacking solution here. So that's soldered together. It's not something you have to buy two different chips. It comes as one chip, but it looks like two different chips. So that's our internal stacking here. Then we have an old stacking thing that we had a long time ago. So here's like it's just if you see it around, we're not actually doing this thing here. So this here was like a L-shaped stacking, and we had I had the one half of another stacking here that allowed you to stack. But our new stacking technology completely replaces this thing here. It's low cost and much stronger. We have the last thing I just want to show you is a couple other xChips. So I already showed you the MDO1, you know that one. And the MDO2 came out when we had our I2C. I talked about that in the daily show about the when we had the AIO 5. What was it? An AIO 1, which was like multiplexing and address chains, and you didn't want to have the I2C moving ahead. We have the same here for something that blocks the serial port, so that's MDO3, and we've been playing with having like a rounded MD21. So if you want to do a circuit and you want to kind of like have it rounded off like that, then we have a chip. That is of course not in production, the other three are, but that just to give an idea about some of the other stuff that we are playing with.